Alright YouTube, so we are back in action after a extended hiatus. I was on the fence about making this video just because this is an unfinished project, but I think it'd be good just to make this video right now as I have over 1,000 subscribers and it would be a shame to let this channel go to the wayside. So what I'm going to show you is this program I wrote in C. As I said, this is an unfinished project, but basically what we're doing is we are reading an image file, a bitmap image file, and then we are reconstructing it in C. I also have some code to apply a filter to it to blur the image. If you take a basically like a college level class about programming in C, they're going to tell you about how to use files. So you could open files to read, and then you could see later we could open files to write. So W to write and R to read a file. One thing that really bothers me about how the curriculum for this is made in college is that they only really teach you using text files. So it's always like something.txt or .txt reading from a text file, or at least that's what they told me. But really, I think that doesn't explain what a file actually is. A file is just it's just binary data. The context of what the file is determined by the program. So that's really what the file extension is about. The file extension is about basically the file extension is telling your program what to do with the file. So maybe if I gave, instead of .bmp, if I gave this a WAV file or something else, obviously it wouldn't work. So we could do some error handling with that. We're not doing that right now because we're using a BMP image. A few years ago, a long time ago, I made a tutorial about how to make BMP images in C. So what we're doing right now is we're doing something a bit different. We are reading an image and then reconstructing it. So for an image, you could just choose anything. If you're going to do this, choose a lower resolution image. Here, I'm just going to take this anime character. Bonus points if you know who she is. It is a 500 by 376 pixel image, and we are going to read it into our program, and then we're going to reconstruct it. This right here is the original image. You see nana.bmp, and this is the reconstruction. See, it's the same image. So our program worked. What a surprise. You can write this in your IDE of choice. Mine is Notepad in Ubuntu. Don't use Windows anymore. It's the year 2026. What are you doing using Windows? You should be ashamed of yourself. Ubuntu's not that good either. But I mean, I have a minimum level of self-respect. So just use Linux when you're programming. That's all I could tell you. And then we are compiling our image using GCC. So this is what the GCC is. We are using -lm. That is to link the math library because we are using math.h file, the header file. And then of course /a.out. We haven't given this file a name, the program, so we're just doing that. Okay, so let's just get into how it works. So first off, we have this function. We are declaring this function because we're going to use it. The function is defined later in the file. So first what we're doing is we are reading the image. So this is just basically boilerplate to read a file. We declare a file type. This is like a structure or something in the file library. And then we are just printing out, opening the file. One thing I'm going to mention is this is a rough program, so it's hardwired for this specific image, the resolution of this file. Once I make the proper version of this program, it's going to be dynamically sized to whatever your file is. but right now, just for demonstration, it's for this particular image. You could change it just as long as you get the resolution right. If we can't read the file, it's going to say could not open file. And then we are declaring a uint8-t. So that is unsigned integer. This type is very important because we are reading bytes, and bytes we'll read as an unsigned integer. Little explanation, this is how a BMP file works. I think I explained it better in my first video about this, but here we have a hex editor. This is imhex. It's a good program to use. It's free on Linux, of course, and then you have it on Windows and Mac or whatever else as well. You have BM, and then all this other stuff in the header. Some of the stuff is important, like where you're saying the size of the image, the print lib resolution of the image, how many colors we're using, whether there's transparency. In this case, there's not. And yeah, that's this stuff is the header up to here. And then each one of these is just the raw pixel data. That's what I like about BMP images, is that they are uncompressed, so they're easy to use. So how it goes is like, I believe it's blue, green, red, blue, green, red, blue, green, red. And that's going from the bottom corner like this, all the way to the top. So we start at the bottom corner. Hex editors are great. We'll learn to use the hex editor so you can learn how to read different file types. Yeah, so we're doing header bytes. This is an integer that's just counting. So basically this data is just, we're gonna just store junk in here. What we're using this for is just to scan through the header, because the header, we know from what the hex editor said, this is 54 bytes long. So basically this for loop is, we're just getting through the header, we're getting to a place in the image where we could get the actual pixel values. So that's how a file works, is that it's read sequentially, at least the way we're doing it. So now we have these big arrays. I'm sure there's a better way to do this, but whatever. This is rough code, but it works, so we're good. The image we're using is 500 by 376 pixels. So if you multiply that together, the total number of pixels is 188,000. And we have 3 channels of color, so red, green, and blue. So we need a unsigned integer array of each of them. And as you see, we're gonna store the image bitmap in RAM so we could work with it and copy the image. So this is gonna say, while we're in the file, we're gonna go byte by byte and scan blue, scan green, scan red. In a bitmap image, this is how it's ordered. So it's blue, green, red, blue, green, red, blue, green, red for each pixel. And we are storing it as a character. A character is a type of unsigned integer. If you think about it, character is 8 bits. And then we are incrementing I to go through each position in the array, fill the respective pixel values. And then we are going to close the file. So we took this file, we copied it into RAM, and then we're done with it. Now the image bitmap is stored in RAM. So now we're going to open a file. This is the output file, and then we're going to write it. The interesting thing about how C works is that if you have the file already exist, it will overwrite it. But if it doesn't exist, it will create a new file, and just a new file with this name in the directory of your program. And then we're going to call this build header function. This is the build header function. We're going to pass the file into it. So then we're just going to build the header. Basically, as we saw, the header is this stuff. So BM, all this other stuff, the resolution and all that stuff. So we're just going to write character by character. Again, your professional software developer person is going to say, oh, this is bad code. Well, it works, so you should have a more creative mindset. So BM, so we're just going to write these directly, and then the file size in bytes, and then all this junk is just 0. It doesn't matter. At least to me it doesn't. And then this 36 is the bytes where pixel data starts. So 36 in hex, all these are hex. I believe that's 54, as we found out. So where the actual pixel data starts. Once we make this program more dynamic, it will change automatically. I'm pretty sure for most bitmap image files it's that. And then this is the length of the second part of the header. It doesn't matter. Width of the image is all these ones. Height of the image is all these ones. These are, again, we're not working them with them right now. We're hard coding them, but it is. I believe this is the least significant byte, and then it goes up to more significant bytes. Same for this one. So these 4 bytes and these 4 bytes define the resolution of the image. So color planes, we're going to use 3 colors. Take note that 0 times 18 in hex is 24. So 8 bits per color, so 1 byte per color, so that checks out. And then all this stuff is 0. This is the size of the image in bytes, so another important thing, so your program doesn't freak out. And then your print resolution, horizontal, print resolution, vertical. This stuff doesn't matter that much. And then all the rest of them are 0. These do have meanings, but not for what we're doing. So we built the header. So we wrote all those bytes into the file. And then we are defining some integers. So blue, green, and red. And then some unsigned integers for blue, green, and red. So these are capital, these are lowercase. And that's just how we're going to do it. So the most basic way of doing this is just recreating the original image. This is how we know we're correctly making it work. So again, this is the original image. This is the copy we made. And then here's some more stuff to cut it off if it's over 255 or less than 255. This is as a result of this stuff where we're rounding and doing mathematical operations on the pixels. I'm not sure if this is necessary. Again, we're just trying to constrain the pixel values within the range of 1 byte. Because, again, these uppercase numbers are regular integers. And this right here is all in a loop from, like, for every pixel in the image. So we're going to copy the values from RAM into these variables, and then we're going to print them out into the file. So copy the pixel data 1 by 1, blue, green, red, blue, green, red, blue, green, red. Then we're going to close the file. Let's compile it. No errors. And let's run it. So as we press enter, you see it flashed up again. So this image updated in the preview. So this isn't very exciting if you think about it. This image is the same as this one. So let's go back to this code that we commented out a while ago. So instead of defining the pixels as the original, let's do something interesting and blur the image. So what we're doing is all this mess is we are basically assigning the pixel. Each pixel is going to be the average of the surrounding pixels, the surrounding 5 pixels. Okay, so what we're doing is for each pixel in this original image, we are taking a 5 by 5 matrix and taking the average of a 5 by 5 area for each pixel and assigning it to the value for the corresponding pixel in the output image. And then we move to the next pixel, do the same thing, average of a 5 by 5 area, and then all the way like that. And the result of this is we can blur the image. So you see we are taking, just trust me, this is a 5 by 5 area, and then we're dividing it by 25, which is how many pixels 5 by 5 equals 25. We commented out these ones, the ones that just correspond to the original image, and then we could And notice how we're doing the round float and then a floating point. So we're forcing all this average to be a float, and then we're rounding it back to an integer. That's just because we're doing math. And this, if we're doing division stuff, there's like integer division and all kinds of stuff. All right, so now we're going to use this code instead of this code. So we're going to save it, and then we are going to go back to our terminal and compile it. And now we're going to execute it. Pay attention to the image. Wow, look, it's blurred. So we can contrast this with the original image. You could see the antenna on her cell phone is visible, and then on this one it's fuzzy. You could see the eyes here are kind of blurry, contrasting to how it is here. So let's zoom in and we could see the differences between these two images. So we are at 943% zoom. All right, so you can really see it now that we've zoomed into both of these images. The one that we applied the blurring mask to is blurry, and the original one is rather sharp. So that's my quick and dirty way to blur an image in C. I don't think I'm gonna upload this code just now, just because it's very specific to this image, or at least this resolution of image. What you really want to do is be able to determine the array size based off of the input image, which we're not doing, it's just hard-coded. And as well, you do have an issue on the edges. Since we're taking a 5x5 matrix, we are taking basically pixel data that doesn't exist. So the edges get a little messed up. But whatever, that's fine. So thank you for watching this video, and thanks for giving me 1,000 subscribers. Hopefully I'll be back soon, and thanks for watching.